Assalamu alaikum students. Today we will be discussing aliphatic elimination reactions. But before going to discuss the aliphatic elimination reactions, we will just want to know that what are elimination reactions and how it works. There are many types of reactions in organic chemistry, but the main classes of organic reactions are addition reaction, substitution reaction, and elimination reaction. The other classes of reactions are mainly derived from these three basic reactions of organic chemistry. In addition reaction, a group of atoms is added to a molecule. That molecule or the substrate must be unsaturated one, like must have a double bond or a triple bond. The addition molecules, the molecules which are adding to that group may be of same nature, like hydrogenation, or the addition of hydrogen, or the addition of halides like chlorination or bromination, or they may be of different nature like the addition of water, the addition of hydrogen halide, and others. Then comes the substitution reaction. The substitution reaction, like we have discussed previously also in the previous lectures, in this one group is replaced by another group, or we can say that one functional group is replaced by another functional group. These has mainly two types: SN1 reaction or nucleophilic substitution unimolecular, and SN2 reaction bimolecular nucleophilic substitution reaction. The third class is the elimination reaction. Elimination reaction is just opposite to the addition reaction. In elimination reaction, a group of atoms are removed from a substrate, from a molecule, and at the end we get a double bond or unsaturation in the molecule. Elimination reaction is a reaction in which elements of the starting material are lost and a new bond is formed. Like, look into this molecule. In the presence of a reagent, you can say that catalyst, these two bonds are lost, and we, as a result, get a double bond between two carbons. In this type of chemical reaction, the removal usually takes place due to the action of acids or bases. It may be also through heating at high temperature. Like if you see in the previous slide that there were two groups attached to the carbons, one was X and Y, and there was reagent. The reagent is maybe acid or a base. In an elimination reaction, the two groups X and Y are removed from a starting material, and two sigma bonds are broken, and as a result we get a pi bond, formation of a pi bond between the two adjacent atoms. Elimination reaction commonly occurs when X is hydrogen and Y is an heteroatom more electronegative than carbon. That may be halogen, that may be nitrogen or oxygen, and so on. In addition to substitution, an alkyl halide can undergo elimination reaction this way, like Y. The Y may undergo a substitution with the X, and we will get CH through CH2, CH2Y, or an elimination will occur with the creation of a double bond between two carbons. This is how this elimination occurs. Like here, we have an alkyl bromide. In the presence of a base, it will undergo an elimination of hydrogen bromide with the creation of a double bond. Water is formed and we get bromide. This bromide, that may be like, if the base is sodium hydroxide, so it will be sodium bromide, or if it is a potassium hydroxide or some other base, so it will be the cation of these base, which will form a salt with the bromine. Our acidic elimination. In acidic elimination, most commonly with the alcohols. Like in this reaction, we see a cyclohexanol in the presence of sulfuric acid undergo elimination or dehydration. We call this dehydration because it's the removal of water. The removal of water is called dehydration, and we get a double bond in the cyclohexane ring, and it becomes cyclohexene. Elimination reaction is mainly used to transform saturated compounds. The function of elimination reaction is that it is used for the creation of unsaturated compounds. The saturated compounds, the compound which have single carbon-carbon bonds, are converted into unsaturated compounds that are the compounds having a double or a triple carbon-carbon bonds. It is the main process or a principal process by which organic compounds having only single carbon-carbon bonds or saturated compounds are transformed to unsaturated compounds. Okay, how to distinguish the elimination reactions, or how to name the subclasses of elimination reactions? Because there are a lot of elimination reactions, but on the basis of the kind of atoms or group of atoms, they are distinguished from each other, and the kind of atoms or group of atoms that leave the molecule, so on the basis of this, they are named like dehydration, when there is the removal of water, or dehydrohalogenation, when there is the removal of a hydrogen and a halogen group. Elimination reactions, as like substitution reaction, are classified as E1 or E2, and this classification depends upon the kinetic of the reaction. Like we are familiar in the substitution reaction that in the SN1 reaction, the kinetics was that unimolecular. The same is the case in the E1 reaction. In an E1 reaction, the reaction rate is proportional to the concentration of the substance to be transformed. And then similar to SN2 reaction, in an E2 reaction, elimination by molecular reaction, the reaction rate is proportional to the concentration of both the substrate and the eliminating agent. The sometimes or mostly the elimination reactions are denoted as beta elimination. Why? If you look into the molecule, there will be a heteroatom that is removed. And with that heteroatom, you can see there is the removal of a proton. And that proton is removed from the beta carbon and form a pi bond. But there are some reactions that are also alpha elimination. What is alpha elimination? Alpha eliminations are those reactions in which both the groups are lost from the same carbon. Beta elimination is that like when two groups are lost from the adjacent atoms and a new bond is formed that is double or triple bond. So one group is called the alpha and the other is beta. Normally if you see the carbon having the heteroatom or the most electronegative atom, here it is bromine. This is alpha carbon and this is the bromine is alpha. And the other carbon adjacent to that is beta carbon. In this case, like if you see, bromine is lost from the alpha carbon and hydrogen from the beta carbon. And that's why it is called beta elimination. As we have previously discussed that alpha eliminations are those reactions in which the two groups are eliminated from the same atom. Here if we see an example of chloroform, in the presence of a base that is sodium hydroxide, it loses hydrogen and a chlorine, and as a result we get a ketene or a carbene species. As a result we get a carbene species. The carbene is very much reactive and it is unstable species and it will undergo further reactions. It can't exist independently. In the beta elimination, the adjacent groups are eliminated from the formation with the formation of multiple bonds. Okay, the mechanism that how these reaction proceeds. The beta elimination reactions proceeds through two mechanisms. One is E2 bimolecular elimination reactions and the other is E1 unimolecular elimination reactions. Here it is to be clarified that all the elimination reactions, they might be E1 or E2, but mostly, or we can say that they are always beta eliminations. There are very rare examples, or a few examples of alpha elimination, or there are also some reactions which are not beta eliminations and not alpha elimination, and they are further apart from the alpha carbon, like 1,4 elimination, or sometimes quite or other further. But in this course we will just discuss only the beta elimination reactions, that is 1,2 eliminations. The E2 and E1 mechanism differ in the timing of bond cleavage and bond formation, and they are similar to the SN2 and SN1 mechanisms. Okay, now we will start from E1, unimolecular elimination reactions. E1 indicates a elimination unimolecular reaction. The E1 reaction proceeds via two-step mechanism. One is the bond to the leaving group breaks first before the pi bond is formed. The slow step is unimolecular, involving only the alkyl halide. The slow step or the rate determining step of the even reaction, it involves only the substrate, that may be alkyl halide, or it's possible that it may be an alcohol, or that may be a nitro compound, but it involves only the substrate in the rate determining step. Like, look into this reaction. This is a alkyl iodide. Hydrolysis of the C1 bond forms a carbocation. This is the step as that is the SN1, as in SN1. It is the rate determining step. It has a first order kinetics. In the step 1, hydrolysis occurs. Why hydrolysis? Because all the electrons, they are gone with the halogen. In this case, the iodine, or all the electrons are gone with the most electronegative species. In this case, the iodine. So we get a carbocation and the iodide ion. Then a base, in this case the H2O, it removes a proton from the carbon adjacent to the carbocation. This is the carbocation, and this is the carbon adjacent to the carbocation, and the proton is removed from that carbon. In this case, all the three carbons adjacent to the carbocation are same, or have the same activity, are similar. So you can remove the proton from anyone. So this proton is removed and this bond migrates here, and we get a double bond between the carbon and the alpha carbon and the beta carbon. A pi bond is formed. Types of elimination reaction. Dehydrohalogenation. The dehydrohalogenation is the removal of halogen and hydrogen. Halogen is removed from the alpha carbon and hydrogen is removed from the beta carbon with the help of a base, and this bond is migrated between the two carbon, and we get a new pi bond between the alpha and beta carbon, and the X is the leaving group. How this reaction occurs? First, the first step is the slow step. This is the removal of bromide ion, and we get a carbocation. Then is the fast step. The base abstract the proton, and we get a double bond and a bromide. The second reaction is the dehydration. Dehydration is the removal of water. This normally occurs in the presence of strong acids like H2SO4, and we get a double bond between two carbons and water. This can be accomplished in these three steps. Like, the first step is the addition of hydrogen ion to the hydroxyl ion, and we get a hydronium ion. Then this water is removed and we get a carbocation and water. Then the first step is the removal of hydrogen from the adjacent beta carbon, and as a result we get the double bond between the two alpha and beta carbons. The references for these lectures were, these are the references, these were all taken from these three books, and maybe throughout these elimination reactions we will be just taking help from these three books, three reference books. Thank you very much. Thank you.